The lesson topic for this video is find the x and y intercepts algebraically for graphing. Okay, so here is the deal. In the previous lesson, we talked about the vertex, the line of symmetry, the x and the y intercepts from, just from some information, and we showed how we could plot those points and that line on the coordinate plane in order to help us draw the parabola. Well, now we're going to be given only some of the information. In this case, I'm going to still give you the equation for the line of symmetry and the vertex, but our job is to find the x-intercepts and the y-intercept so we can graph the parabola. And let me show you why this is important. If I were to graph right now the line of symmetry, x equals 1.75, notice that 1.75 on the x-axis is right around here, right? So if we drew a vertical line right through there, and I'll do my best again on my iPad to do that. Okay, something like that. It's a little bit off at the end there. So that's a vertical line at x equals 1.75, and we know the vertex for we know the vertex is always on the line of symmetry because it cuts it into two congruent parts on either side. So if I put a point at 1.75, comma 1.125, I would get a point approximately right here. Right? That point right there is at 1.75 on the x-axis and 1.125 on the y-axis, and that's our vertex. So now here's the problem. We can't graph this parabola right now because we don't know how the rest of it looks. Does it open up really wide this way? Does it open down really narrow this way? Does it open even wider that way? We don't know how the parabola goes. So in order to figure that out, we're going to find our x-intercepts and our y-intercept to help us graph the parabola. Okay, so we know our x-intercept or intercepts. In this case, we know there's either going to be 0 or there's going to be 2. There's not going to be an option for just 1. And let me show you why. Again, when I just said that a minute ago, we could have the parabola open up this way, and if we did, then there are no x-intercepts, right? But if we had the parabola open the other way, this way, then we have 2, 1, 2. But we will never have just 1 in this example because the vertex would have to be on the x-axis to have just one x-intercept. All right, so x-intercepts are found by plugging 0 in for y and then finding the x value. And again, we're either going to have 0 or we're going to have 2. All right, so if we plug 0 in for y, right? Plug 0 in for y. We're going to take this equation, we're going to plug 0 in for y, and you have seen this before. All right, if we plug 0 in for y, we now have a quadratic in standard form over here equal to 0, so it's already set equal to 0, and we know how to solve this algebraically. We can solve by quadratic formula or factoring, whichever one works. Now, quadratic formula will always work, but we could check to see if factoring works first. Remember, once it's set equal to 0, we're ready to go with that. Step 2 would always be to look for a GCF. Remember that? So we're going to look for a GCF, and we do have one here. We can factor out a negative, which will actually make the problem just a little bit easier. So when I factor out a negative, I get 2x squared minus 7x, because the sign changes, plus 5. Step 3 is to look to see if we have an a equals 1 or a equals something other than 1 to see if it factors, right? To see if it factors. Our a is 2, and so we'd have to look for magic number here. So I'm going to slide over to the side and write 10x squared. And I'm going to think about my factors of 10x squared. So 1 times 10 or 2 times 5. And we realize that 2 times 5 is going to work because 2 times 5 is 10 and 2 plus 5 is 7. We need negative 7 here, so we do need to remember to make both of these negative. A negative times a negative will still become positive 10, and these will add up to negative 7. So this will work for factoring. Now, if you'd prefer not to factor and you'd prefer to do the quadratic formula, you can. But I prefer to factor if possible. So now I'm going to undo that. Okay, so I'm going to bring my negative, let's try this one more time. I'm going to bring my 0 and my negative down into a couple steps lower in my work so that I have some space to do my magic number. All right, so I'm going to rewrite 2x squared and then the plus 5 over here, And I'm going to squish the minus 2x and the minus 5x in here. You guys, this is nothing new to you. We've done this, so just put this in here. And we're going to put that vertical line down right here. We're going to factor out the GCF of both sides. So I'm going to factor a 2x out of this side. And I'm left with x minus 1. I'm going to factor a negative 5 from this side, and I'm also left with x minus 1. Take a minute and try that out on your own if you need to look at that a little bit slower. So we're going to get 0 equals the negative symbol out here. Now that x minus 1 matching parentheses, it's good that our parentheses match, right? Right here and right here. So I'll write that first. And then I have 2x minus 5. So what we have now is we have the zero product property. And the zero product property says if two things are being multiplied together and we get the answer of 0, one of those two things must equal 0. So I'm going to use my space right here. This is getting a little bit squished here. I'm going to use my space right here to do these. So x minus 1 equals 0, or 2x minus 5 equals 0. And we solve these. So x equals 1 when I add 1 to both sides. Over here, if I add 5 to both sides, I get 2x equals 5, and I still need to divide by 2. So I'm going to get x equals 2.5. So we now know that our x value here and our x value right here tell us our two x-intercepts. So we can put a 1 right there and a 2.5 right there. So we have done quite a bit of work there in order to find our x-intercepts. So let's go ahead and put those on our graph. 1, 0 is right here. And then 2.5, 0, 2.5, 1, 2, 2.5 would be right here. So those are our x-intercepts. Now we pretty much know the shape of the parabola at this point. We know from the vertex it's going to curve down very narrow here, both sides. We are just going to find our y-intercept to make sure it makes sense, because sometimes we end up checking ourselves and figuring out that we did something wrong just by looking at the fact. Let's say our y-intercept says 7, which is right here. Well, then we probably know we factored wrong. So it's a really great checkpoint for us to make sure that we've done things right. So remember that a y-intercept is found by putting a 0 in for x and finding the y value. Remember that means we can simply use trace on our graphing calculator, because when we know the x value, we can just use trace on our calculator. And when we use trace on our calculator, we're going to find out that y is negative 5. So our y-intercept is right here. Y-axis negative 5. And so now we are able to draw our parabola from this vertex up here through the x-intercept, through the y-intercept, and it carries on that way. And we know it's going to be congruent on the right-hand side. It's going to come through this x-intercept and down like so. So we have graphed the parabola that matches this equation right here by finding our x-intercepts and our y-intercept. Now the second example, not only is it in function notation, which is good to keep revisiting, but also I just want to point out that it is in what we call vertex form. So it's not in standard form, so we're going to solve this differently for our x-intercepts. So first, let's go to x equals negative 2, a vertical line at negative 2, and we know our vertex is at negative 2, negative 9. So negative 2, negative 9 is right here. And even though it's very low on this coordinate plane that's shown, it doesn't automatically mean that it's going to open up. It could still open down, and we would need to find out our y-intercept or our x-intercepts to make that determination. All right, so those are done. So our x-intercept, remember, our x-intercept is, or intercepts, is when our y value is 0 and we're trying to find x. And our y-intercept is when we know our x value is 0 and we're trying to find y. All right, so this time we're going to put 0 in for y, as we see right here. We're going to put 0 in for y, or in other words, f of x. So we'll put a 0 in, and we will see what we have. So thinking about the process for solving quadratics, we realize right away that we are in what we call an undoing type of example. When we have the parentheses in vertex form, we're going to be solving by undoing the PEMDAS steps to get the x alone. Okay, so remember that's, PEMDAS from here up. So we're going to start by adding 9 to both sides of the equal sign. So we don't need it to equal 0. We need it to everything to be brought to that other side. So we get 9 equals 3 times x plus 2 squared. Now we undo next. We did our adding and subtracting. We multiply or divide. So we're going to divide both sides by 3. And we get 3 equals x plus 2 squared. And now we deal with our exponent. So we square root this side to cancel the square, and we square root this side. This is super important. Remember that we put plus or minus in when we have a square root. And we get plus or minus 1.732 equals x plus 2. Lastly, we're going to deal with what was in our parentheses, which is the plus 2, which means we're going to subtract 2 from both sides. Remember, at this point, we're going to write, this cancels, x equals positive 1.732 minus 2, or x equals negative 1.732 minus 2. All right, so we're going to get our two values here. Our first one is negative 0.268. Negative 0.268. Sorry, that's a little sloppy. And our second one's negative 3.732. So those are the values that I would write in these spaces right here. I just realized they're kind of small right there. So if I want to just think about putting these on my coordinate plane, they're my x-intercepts. So negative 0.268. Well, that's negative right around a quarter. So negative 0.268 would be right there. And then negative 3.732. So negative 3, 1, 2, 3, more than negative 3.5. So we're going to be over in this region here. And they should always be symmetric on different sides of that vertical line of symmetry. So if they're about the same distance away, that's a good thing. That means we're doing it right. So that looks pretty good. Now we're going to go ahead and find our y-intercept by putting 0 in with trace. Remember, this is using trace. And we get 3 when we use trace there for our y-intercept, which is right here. And that matches and everything looks good for drawing that parabola. All right, so we know it's coming through that x-intercept down here. Make sure it doesn't look like a V, but a U shape. It's tricky to draw sometimes. Back up through there and on our way. There's our parabola.